Welcome to another gas stoichiometry example with Miss Taylor. In this particular problem, we are looking for the number of grams of potassium chlorate that would be needed to produce 5 liters of oxygen at 112 kilopascals and 25 degrees Celsius. Now, our units don't look too bad to begin with, but of course we always want to change our temperature to Kelvin. Okay, and we're starting from a volume. Now, if this was at STP, we could use molar volume to convert directly from volume in liters to moles. But since we don't have STP conditions, we have to use the ideal gas law to begin with to get the number of moles of O2, because when you're working stoichiometry, to get from substance A to substance B, you got to have things in moles. So that's going to be our first step. Ideal gas, or perv-nert, as we affectionately call it in my class. So our pressure is in kilopascals. Now, let's see, 112 kPa. Volume is 5 liters. We're looking for N. Now this is where R is a little tricky. The R value, remember, is supposed to depend on the unit of pressure. And in this case, since we are using kilopascals, it is 8.314 kilopascals per liter, or kilopascal liters per mole Kelvin. And then we went ahead and wrote down our temperature in Kelvin, so we've got all that. Alright, so multiply 112 times 5 and then divide that by whatever 8.314 times 298 is, and that should give you 0.226 moles of O2. Now that we've got moles, we can use some traditional stoichiometric relationships to do what we need to do. Okay, so 0.226 moles of O2. Okay, since we're at moles, we can go ahead and jump to the mole ratio to get us from O2 to KClO3. And according to our balanced chemical equation, there's 3 moles of O2 to every 2 moles of potassium chlorate. And then our answer wasn't supposed to be moles, but in grams, and hopefully we remember that molar mass is what we use to convert from moles to grams, and I'd already calculated the molar mass of potassium chlorate. So you should do 0.226 times 2 times 122.55 divided by 3, and rounded to 3 sig figs is 18.5 liters of O2.